Hello. In this video, we want to delve into how to use wildcards to match or search file patterns in commands. You already know the different wildcards that exist, and today, I would like to demonstrate how they are used. But first, let's open our terminals and navigate to our preferred directory. After opening the terminal, let's confirm our current working directory using the pwd command. We are currently in the home directory. I prefer working in the Documents directory. Therefore, let's change the directory to the Documents directory using the cd documents command. You can choose a directory you are comfortable with. Let's just confirm that we are in the Documents directory using the pwd command. And indeed we are in the Documents directory. The next thing we should do is to check whether or not there are files in the Documents directory. Type the ls command to check. In our case, there are no files or subdirectories inside the Documents directory. We need to create several files to use for this demonstration. We will create 12 files with different file names and extensions. Let's use the touch command to create these files: file1.txt, file5.txt, file10.txt, file12.txt, file3.fasta, file7.fasta, file15.fasta, file20.fasta, file.pdf, gene.fa, text.css, and com.fa. If you click Enter and receive no errors, then your files have been created successfully. You can confirm this using the ls command and you will see all the 12 files you have created. Next, we want to use different wildcards to search or match these file patterns in our commands. In most cases, wildcards are used when handling several files. Let's start with the asterisk wildcard. Let's say you want to ls all files ending with the extension .txt. The command you should use is ls*.txt. This lists all files ending with .txt in your current working directory, which are only 4 from the 12 we created. The same syntax applies when listing all files ending with .fasta. The command is ls*.fasta. Only the 4 files ending with the .fasta extension are listed. Let's say you have several documents and they are named starting with file plus a number or any other character followed by the documents extension like file1.txt. If you wanted to list all documents named file plus 1 character before the documents extension, you use the command ls_file?.txt. This lists only file5.txt in our case. Take note that Linux is case-sensitive and file5.txt with a small f and file5.txt with a capitalized F are not the same. Let's use capital F instead and see the result. Type the command ls_file?.txt and click Enter. You get file1.txt because it is the only document with a capital F and 1 character after the name file. If you wanted to list documents with 2 characters after the file name, you use 2 question marks instead of 1. For instance, the command ls_file?.fasta will list all files with the name file plus 2 characters before the .fasta extension. In our case, it is only file20.fasta. Let's use a capitalized F instead and see the result. Type the command ls_file?.fasta and click Enter. This will result in only file15.fasta. The question mark wildcard can also be used in a different way. Let's say you have several files and you want to list files that are named using only 4 characters. In that case, you will use 4 question marks, then you add your preferred extension. For example, let's say you want to list all files with 4 characters as their name with the .txt extension. You will use the command ls .txt. In our case, there are no files or directories with 4 characters as their name ending with the .txt extension. All the files ending with the .txt extension are either named using 5 or 6 characters. Let's try another command. Type ls .pdf and press enter. In this case, we will get file.pdf because its named file is made up of 4 characters. Let's use a different extension. Let's type ls .fa then press enter. In this case, 2 files are listed, namely gene.fa and com.fa because the names gene and com are made up of 4 characters. Let's go back top the asterisk wildcard for a minute. You can also use the asterisk wildcard to list or perform other operations on files whose names start with a specific letter or character. For instance, let's say you want to list all files starting with a capital F and ending with the .txt extension. You would use the command lsf *.txt. In our case, you get only 2 files, file10.txt and file1.txt. Let's try this using the .fasta extension. Type lsf *.fasta and press enter. This will list all the files starting with a capital F and ending with the .fasta extension. In our case, there are only 2 files, file15.fasta and file3.fasta. You can as well use the syntax without specifying a file extension. In that case, all the files starting with capital F will be listed regardless of their extensions. Type lsf * and press enter. You will realize 4 files are listed, all starting with capital F. 2 ending with .txt extension and 2 ending with .fasta extension. In some cases, you would want to list files in a specific range. For instance, since our files are named file 1, 2, 3, and so forth, you would want to list files, for instance, between 1 and 10. In that case, you use the command ls file, 1 to 10, .txt and press enter. In this case, only file1.txt is listed, yet we also have file10.txt, which is in that range. Why is that? You might ask. The reason is, the bracket expression 1 to 10 is a character class, and in this context, it matches only single characters, 1, 2, up to 9, as well as the character 0. It does not treat 10 as a whole number. So, the shell looks for files like file1.txt, file2.txt, and so on, but not file10.txt. Let's create another file to test this theory. Type touchfile5.txt and press enter. Let's confirm that the file is created successfully using the ls command. Here it is created successfully. Let's try our earlier command, ls file, 1 to 10, .txt and press enter. We still get the same file, only file1.txt, yet we have file5.txt and file10.txt as well. What if we change the range from 1 to 10 to 1 to 9? What happens? Let's try that. Type the command ls file, 1 to 9, .txt and press enter. In this case, we now get the correct number of files, which include file1.txt and file5.txt because the bracket expression matches only single characters. What if you would like to include files with double characters like 10, 11, 12, and so forth? What syntax should you use? In that case, we should use curly braces instead. The command should be lsfile 1.10.txt. Type that and press enter. You will realize that when you use curly braces, the command will try to find all the files within that range. If a file exists, it will be listed. If a file does not exist, the output will be no such file or directory exists, like we can see in our case. The output is that file 10.txt, which is now listed as opposed to the previous command, file 1.txt, and file 5.txt are listed, while all the others in the range of 1 and 10 are listed as not existing in our current working directory. These wildcards can be used when performing several other operations in Ubuntu, not just listing them. For example, let's say you want to delete or remove all files with the .fasta extension. All you need is the command rm**.fasta and press enter. No error indicate all the files ending with .fasta have been removed. You can confirm this using the ls command. Similarly, you can decide to remove all files starting with a capital F using the command rmf** and pressing enter. Again, no errors indicate that the files have been removed successfully. Confirm that using the ls command. As you can see, there is no file starting with a capital F. And that's it. That's how you can use wildcards to perform various operations in Ubuntu. Consider subscribing for more of this content. Thank you.